still morning, right? Good morning, everyone. So I'm Aleysia Kleinert from Stellenbosch University at the Horticulture Department. So still relatively new to macadamia research. 2 of the projects started only last year, and the 3rd one started this year. So I'll start off with the first one. So the aim of this project is to investigate the quantities of the nutrients that are removed during macadamia harvest. So as you all know, nutrient removal, together with visual assessment of your tree, plant and soil analysis, as well as crop yield, play a very important role in setting the scene for your fertilizer management program. So estimates of nutrient removal through nut in husk harvesting is based on very limited data that is available from Australian studies. I think in the 60s they did a project and they used 20 nuts only for a few cultivars, so that's hardly a representative sample. And then the project was repeated during the 90s where they did nut in husk harvest for 3 cultivars, and then they only averaged the data and extrapolated all their recommendations from that. So the aim of this project is then to define nutrient removal values for all the components of the nut, so the husk, the shell, as well as the kernel, for 8 specific varieties. I also just need to mention that this project is a repeat of work that has been done by Jeremy Bright. So he actually suggested this project to SAMAC and to myself. And so Jeremy has done this part of a similar part of the work already in New South Wales, and we have 3 internal controls to compare our data with each other. So what we did is the cultivars or varieties that we decided on was Nalmac 2, Beaumont, 788, 814 and 842, with H16, A4 and A16 as the internal controls between Jeremy and my projects or studies. So the sampling we decided to do in both Mpumalanga and KwaZulu-Natal, and at the south coast of KwaZulu-Natal, I must just mention, and at 3 time points during the season. So it would be at the start of the harvesting season, a midpoint, as well as end point, just to give us an average of the nutrient content in the different components. As far as possible, we try to have all the cultivars or varieties on one farm, or as close as possible localized to each other, just to be able to discard any farming practice anomalies and also climatic interferences. So I repeated this study across 2 seasons. So last year was the first one and repeated it this year. And the samples were then sent off for ICP analysis at Central Analytical Facilities at Stellenbosch. So basically what happened is I would go into the orchard and I would collect roughly 2 kilograms of green nut in husk, not split nuts from the tree preferably, or if they had just been harvested, I would collect from the wagon from the tractor. I would take them back to Stellenbosch and weigh them to get the total weight, dehusk them immediately, cure the nuts in the oven at about 35 degrees until we reached a moisture content of 1.5%, because unfortunately it needs to be very dry for the ICP analysis and milling to take place. So then just some preliminary findings. So this is for the Mpumalanga husks. I'm waiting for the kernel and the shell data, but just to show you that there is huge variation in the nutrient percentages for the different husks, okay? And with no clear pattern really at this stage then of which husk contains the most nutrients. However, once I correct for the total husk weight as a percentage of the nut in husk, you will see that 788 is by far the most nutrient-dense husk of the group. Okay, and this then makes sense as 788 has got the thickest husk of the cultivars. Okay, so the green just shows the highest values, and the red just shows the lowest values of the different cultivars. So that's for Mpumalanga. Then if we look at KZN, we also see quite jumbled up if we just look at percentage content, okay, so not taking into account weight correction. But then when we correct for the weight and we express it as kilogram of nutrient per ton of nuts harvested, we'll see that again 788 has got the highest nutrient concentration, but interestingly lower than what we saw for Mpumalanga, and this makes sense as the 788, as you all know, has got a thinner husk on the Natal South Coast. Okay, so then what I just also want to mention is that the nutrient values that we found in these husks are very similar for the ranges reported of those in the Australian study. Okay, so similar to what Jeremy found for his cultivars, and then also similar to the ones that they reported for the 3 cultivars that they just averaged. But it's still early days, so we might see big differences coming in the nutrient concentrations when we add the shells and the kernels to this data as well. And I'd be very interested to see whether, as a nut in husk unit, whether you have kind of the same nutrient removal and whether the different cultivars have different allocation to the various nut components, or whether we see that some cultivars do partition just a whole lot more nutrients to their nuts than others. And then the yellow trees. Okay, so yeah, so this project, to say this is a challenge is probably the understatement of the year. So I know a lot of people have looked at this already, and I mean, obviously it's a huge industry problem with the yellowing trees having a decline in their production. And so far the studies have proven quite inconclusive. We're not sure if it's an abiotic factor or a biotic factor or what exactly is going on. So macadamias, and like all members of the Proteaceae family, have evolved to grow in phosphate-poor conditions. But now the problem with these type of plants is that when you give them sufficient phosphate, they don't switch over and realize that they actually have sufficient phosphate. They just keep on taking up the phosphate that is available, which ends up leading to toxic levels in their leaves. And one hypothesis that has been put forward is that these high levels of phosphate in both soils and leaves can then immobilize the iron that is present, rendering it biologically inactive. Okay, and this then leads to the chlorosis of the leaves that you see. Another hypothesis, and this is also specific to the Proteaceae grouping, is that the phosphate forms complexes with zinc, so which also leads to chlorosis. So definitely chlorosis is the big thing, but why, we don't know just as yet. And then also researchers in Hawaii have reported that they found that there's a critical iron to phosphate ratio in the soil. And if this ratio is equal to 60 or higher, then the trees do not develop any chlorosis, but as soon as this ratio goes below 60, then the trees develop chlorotic symptoms. So, and then just to confound things further, we know that long-term agricultural production can also lead to micronutrient deficiencies in the soils, but the tricky thing with micronutrient deficiencies is that they don't always present visual symptoms. Okay, so now having all these various options to consider, we decided that maybe the best thing is to start with the basics and to develop a baseline assessment of nutrients that are in the soils and in the leaves for these chlorotic trees. So what we did is we identified, Skulk identified 8 farms around the Wit River, Nelspruit, Barberton area that reported quite extreme chlorosis or yellowing trees. And so what we did is we went onto the farms and we would identify 3 trees, not spaced together, spaced quite randomly throughout a block. And we would take soil samples from them. And in the same block, on the same farm, we would also identify 3 healthy trees and also take soil samples from that tree. We tagged the trees. We collected soil samples during July, and we tagged the trees, and then during November, I went back and I collected leaf samples from these trees. So, and together with that, there was also one control farm that did not have chlorotic trees, but was from the same area that we just collected soil and leaf samples from, just as a positive control, just to compare, to make sure that we weren't maybe missing something. So what was nice is we actually had healthy and chlorotic trees then on the same farm, so we at least knew that if we saw any differences on those farms between the soils and leaves that we test, that it would not be due to farming practices. I make it sound so easy, but then, so I brought the soil back to Stellenbosch and brought the leaves back to Stellenbosch. The soils, we measured the pHs. The soils were then milled and sent off for MS analysis. So because I was curious, because I was thinking maybe it's a micronutrient, maybe it can even be a trace element or a heavy metal toxicity. So that's why I needed to have the soils analyzed via mass spectrometry. And then the leaves, we are also having analyzed via mass spectrometry. But the devil is in the lack of details. So the soil data came back last week, and it shows nothing. There are variations between farms, but when I look at healthy versus sclerotic trees, there are no differences. The phosphate levels are the same, the magnesium levels are the same, the calcium is the same, they even have the same levels of chromium and things. So pHs are the same, so it's not a high pH. I mean, the pH for most of the farms were in the range of 5.5 to 6.5. There were some farms where it was a little bit lower, but then again, it was the same for both. I don't want to call them treatments, because yellow trees are not really something that you aim for, but it was the same for the healthy and the chlorotic trees. So we're ending up with more questions again than we have answers. But one thing that we did notice as we were collecting these samples is that as we were digging the holes, we definitely noticed a difference in the root health between the healthy and the chlorotic trees. And I think that's definitely something that we need to consider investigating in a follow-up study. And it's also difficult to draw any real conclusions at this stage, because while there might not be any differences in the soils, I don't know if there is maybe something happening in the root that will translate into different results that we will see in our leaf samples. So I will share that with Aleysia as soon as I receive it. But if you have any other suggestions in the meantime of what we should be looking at, please feel free to share them with us. Okay, then the last project that has started this year and that I have a master's student working on is to add our bit to updating the phenological calendar for the South African industry. So, as you all know, the carbohydrate status of macadamia trees go through peaks and troughs, and during late July, early August, there is a peak in carbohydrate reserves, and this drops down then to a low during the spring flush around September and then early October. So the aim then of Roche's project is to time in the timing of shoot flushes and root flushes with these fluxes that we see in carbohydrate allocation, and to see if we can use kind of the carbohydrate status as an indicator of what kind of flush, either root or shoot flush, to expect, or just to know that if you have a flush or a carbohydrate status of this level, then what kind of flushing or flowering can one expect for the next season. So what we did is, see, I didn't include that. So if we're doing this study on the 4 biggest cultivars currently in the industry, so 816, NALMAC 2, Beaumont, and A16. And we have identified 3 sites around the Nelspruit area where Roche is taking monthly samples from the trunks. So what this entails is we label trees right at the start of the year, and then every month he goes back and he collects tree trunk samples. So with a drill, and this sounds terrible, he drills a hole into the tree, not very deep, just about 4 millimeters, and then cleans that out, and then drills a little bit deeper, and he collects those shavings, because now he's gone through the bark and through the phloem, so now we're in the xylem tissue where storage usually takes place, and then he collects these samples, and we collect samples, about 10 samples from a farm, and then we group them together so we have a few reps for each farm, and then he seals up the wound very nicely again. And at the same time, he will also collect leaf samples from the same tree. And this is just so that we can correlate the carbohydrate status of the leaves with the carbohydrate status of the trunk samples to see what is the relationship and whether it might not be easier in the long run to just collect leaf samples instead of trunk samples to give you an idea of carbohydrate status. The reason why we included the trunk sampling in this study and not only opted for leaf sampling is because Vimpani did quite an extensive survey for the Australian macadamia industry, and all their sampling was done only using trunk samples. So then the second part of what Roche needs to do is he also needs to measure the flushing of the roots, so the timing of the root flushes and also hopefully the extent of the root flushes. And the samples that he has collected then from the trunks and the leaves, we will also have analyzed for nitrogen, just to give us an idea of monthly and hopefully seasonal patterns of nitrogen allocation and reallocation in the trees. So just to show you how the root flushing will be done is he will make use of a mini rhizotron. So basically what we have is just 1 meter long perspex tubes, and you dig a sluit or a hole next to your tree in the orchard row, and you just install the perspex pipe in there at a 45-degree angle. This slide shows you the two ways of doing it. The straight down installation is usually used for annuals like grasses and maize. So by installing it at a 45-degree angle, it enables you to take a 360-degree photo of your root every time you do a scan. So on his next trip to Nelspruit, he will need to install these tubes and then leave them for about 2 months to settle and for the roots to just start growing nicely around them. What then happens is every time he comes back to Barberton, it's basically a scanning camera. So it scans about a 20 centimeter wide image at a time, but it is able to turn in a 360-degree angle. So it can measure above where it's scanning and below where it's scanning. So you get a nice visual representation of your root growth over time. So these scans, he will then analyze using specialized software called RootSnap, and this just enables the students to then map the thickness of the root and also to see what is new growth and what is still of the previous month's growth. So kind of a qualitative assessment of root flush and not so much quantitative, but it gives you a nice idea of the extent and the timing of the root flush. Okay, so that brings me to the end of my overview. So I just need to say thank you very much to SAMAC, without whom neither of these projects would be possible. And then thank you very much for the growers that allow us to do all these things on their farms. So for collecting the nuts and allowing Roche to drill holes into the trees. And I know everyone was quite nervous when all of that started out, but it seems to be working okay. And then I also want to say thank you very much for the technical advisors that have helped put me into contact with suitable growers that I needed for all the specific varieties. And then yes, I think that's it. Are there any questions?
Thank you. I just want to know, did you find any differences with the carbohydrates between the leaf samples and the stem samples at this stage?
Yes, at this stage we have, and it seems that the leaf samples, the concentration is a little bit higher, but the way we do it at the lab at our department is we actually don't just test for total carbohydrates. We split it into 3 components, so then we have the water-soluble, the sugar alcohols, and then the starch. So we don't know yet what the composition of the different groups are. He just has an idea of total, but that's also just preliminary data for one trip. So we don't know yet how it's going to develop over the season.
Any other questions?
Hi, also with the carbohydrates. Just want to find out if there's any scope in the project to overlay yield data on the carbohydrate that you're measuring.
That's a very good question. I've actually asked Rashay to make sure that because he's working in dedicated blocks, to make sure that he speaks to the growers and get an indication of their yield for the previous season, the season where he's busy now, and then also following up with them at the end of next season, just to see if we can correlate the data with the carbohydrate status.